Hey guys, welcome to your 9th C# tutorial, and today we're going to talk about the math class. Now what the math class is it's an easy way for you to do simple mathematical operations other than addition, subtraction, multiplication, division, etc. The first thing I want to introduce to you in the math class are two attributes that are constants. You can't change them, they don't return any values or anything, and that is math.e and math.pi. Now, if you're familiar with any, if you've ever taken like Algebra 2 or even pre-calculus or trigonometry, then you know pi and you know e. E is Euler's number, 2.718. It's used for exponential growth and decay. Pi is used for circles and triangles, trigonometry and stuff. So let's go ahead and run this, and hopefully it'll print out 2.718 and 3.14159. Let's run. 2.718, 818, 28, 45905, okay, whatever. I'm not going to give you a math lesson as to how they calculate these, but that's what that does. And now, the reason I have to actually put these in a console.writeline is because they're variables, basically, so... And everything in the math class is a return method, and I'm going to talk about that probably in the next tutorial, or in the tutorial after that when I start talking about different how to make your own classes and stuff. So the next method I want to teach you about is the absolute value method. Let me go ahead and comment that out. Math.abs. Now, if you know about math, again, absolute value is it's the distance a number is away from 0. So this should print out 5. It's always positive. It basically just takes a number and makes it positive. So there's that one. Math.ceiling, math.floor, and math.round. I need to show all these at the same time. Get rid of that. Math.ceiling. I think I spelled it wrong. I did. Math.floor and math.round. IB4E except for after C, guys. 5.0, let's see, 6. Let's do 5.6 for that one. And then for this one, let's do 5.445. Let's copy this, do 5.545, and this one do 5.0001. And let's run this, and what math.ceiling does is it rounds it up, no matter, as long as it's greater than 5, it'll round it up to 6. So that's why that comes out as 6. This one comes out as 5 because even though it's greater than 5, your normal rounding rules don't work. It basically floors it. It just drops it down. It drops the decimal, basically. Console.writeline, math.round will round it with normal rounding rules. So this one rounds to 4. And oh, that one should have rounded to 5. I accidentally did the wrong number. I mean 6. Yeah, there we go. So it rounds to 6. There you go. Okay, those are those methods. The other ones I want to talk about are the log methods. Math.log, log with a capital L. Got to capitalize everything. Log, and then log 10. Log does not do a log. If you're familiar from Algebra 2, it actually does the natural log, and so it should really be like math.ln, because that's how it is on the calculators. And then log 10 does log base 10, basically. So let's do math.log of math.e, and that should give us 1 for both of those, which it does. And I'm not going to tell you why, but because if you know your logarithms, then you should know that. Min and max, that's obvious. And the way you actually do these is you put in 2 numbers. 2 and 5 work. Why am I getting an error? It says, oh, right. And then min 2 comma 5, and there should be another parenthesis there. So it should say 5 and 2, and it does say 5 and 2. Power and exponent, math.pow, which I actually showed you in the previous video, I believe. Let's do math.exponent. Let's see. Let's just do squared. Okay. And then that should be that. Okay. And then this is going to be like 5 comma 2. So it prints out 25 because it's 5 squared. Oh, I missed one. Whoops. E to the power of 2, Euler's number to the power of 2 is that, I guess. And then 5 to the power of 2 is 25. So those are self-explanatory. I wasn't really sure about the difference between exponent and power, but it says right here, returns E, which is Euler's number, raised to the specified power. So that's what that does. And then there's the square root, which looks like squirt, but it just basically takes a number and square roots it. So let's do square root of 25, I mean. And have another error. Square root of 25. 5, 25. Okay. Now we have some trigonometry methods that I just kind of want to type out here because I don't really need to show you. If you know about trigonometry, then you'll be fine. Math.cosine, math.tangent, and I don't actually know what sine h means or cosine h. I think it's like hyperbolic sine or something, but I've never actually done any of that before, so I wouldn't know what it was supposed to come out with. Now, a sine is arc sine, basically inverse sine. It's when you're trying to find the angle measure, and these all return angle measures, by the way, except for sine, cosine, tangent. Those don't return angle measures. Those return the ratios. Again, if you don't know anything about trigonometry, then you can pretty much disregard this because you're probably never going to use these. And then math.atan2. I'm gonna have to show you what that actually does. It says returns the angle whose tangent is the quotient of 2 specified numbers. I think that sounds exactly like atan whose tangent is a specified number. I don't really know the difference because I always thought the tangent was the quotient of 2 specified numbers. But anyways, those are those methods. And then the rest of them are some that I don't really know what it would do. These apparently have something to do with 32-bit. Let's see, what did it say exactly? I don't care. Big mule. Looks like big mule. Produces the full product of two 32-bit numbers. So I mean, I don't know what that does. Math.big mule. And then div rem. That has something to do with 2-bit numbers. Equals compares 2 objects to see if they're equal. More than likely it has something to do with the memory address. Determines whether the specified system.object instances are equal. So I guess if it's just an object, then it tells you whether they're equal, because you can't use the equals operator for that. This one's really weird. Remainder. I don't remember what that one does, and I probably would never use it. This is reference equals. This basically compares 2 objects to see if their memory references are the same, which we're gonna have to talk about the memory references and stuff. It's like about pointers and things. Sign, you give it a number and it returns the sign. So if it's a negative number, it will turn a negative. If it's positive, it will return a plus sign. And then there's also math.truncate, which does something with a calculates the integral part of a specified double precision floating point number. Don't really know what that means because I don't know what truncating is. But anyways, those are all of the math classes, math class methods, and They're all static, so it requires no creation of an object. In fact, I don't think you can create an object. I think it's an abstract class, but I'm going to hopefully get to abstract and object, etc. and within the next couple of tutorials. And in the next tutorial, we actually are going to be creating our own class. We're going to make a calc class to do basic mathematical calculations, just so I can use that as an example to teach you the basic idea of making your own class and how to use the methods within the class other than what we've already done, just so you can understand why we type out math dot whatever and things like that. So hopefully that'll be a lot of fun, and I'll see you then.